Okay, so greetings everyone. Welcome to this presentation um, of submission 42. My name is Junqing Tang. I'm a postdoc research associate from the Center for Smart Infrastructure and Construction at University of Cambridge. This paper was a joint effort by myself and my colleagues. The second author, Dr. Jennifer Schooling, she's our center director. Dr. Li Wan is from the university's Department of Land Economy, and Dr. Timea Nochta is also a postdoc research associate from the center. Right, so this paper is focusing on revealing functional roles for built environment professionals using a network approach. It is an investigation on digital tasks and digital competences of people who participate in planning and managing the digital transformation of cities. So, digital technologies and tools have brought novel opportunities and challenges to the built environment and have profoundly shaped the way we design, manage, and make decisions. Built environment professionals and organizations are inevitably facing increasing challenges when embracing digital transformation. Among them, one very important challenge for practitioners and organizations is that do we have the fundamental capabilities to leverage those digital technologies and tools? To address this challenge, it's very essential to decode the relationship between digital tasks, which is what to do with tools, and digital competences, which is how to use tools. Furthermore, it is also, of importance to better understand and define functional roles which individual or a team should play within organizations. However, as the digital tasks and digital competences are becoming increasingly complex, identifying functional roles could be particularly intractable in practice, especially for those hidden roles that are often covered by complex interdependent relationships. So in this paper, we use quantitative network model and a community detection method to perform a role discovery exercise based on an investigation of digital tasks and competences. So the objective is to seek possible ways to identify important or missing functional roles for practitioners and ultimately support the development of a competence framework. So before we dive into the method, very briefly, let me explain this conceptual framework regarding the competence framework we are developing right now. We frame the competence framework around these three important pillars, which are tasks, competences, and roles. In general, identifying roles is more difficult and intractable than the other two. So this is why we want to discover roles based on the tasks and the competences. Of course, this study is not the first attempt to look into the digital tasks and competences. To come up with the digital tasks and the competences we need for this role discovery exercise, we started from understanding what are the major digital tasks and competences in the literature. Some good examples we used include the data skill framework from Open Data Institute and the Digital Competence 2.1 from European Commission. And finally, we've got 12 digital tasks such as data generation and collection, analytics and modeling, interpretation and recognition, and review and update, and more for the digital tasks. Also, we have defined 9 digital competences, such as digital security and safety, digital content development, troubleshooting and problem solving, and more for those 9 digital competences. With these building blocks, we can then apply the methods. So a network approach was adopted to explore the possibility of role identification. Very briefly, what we do is to establish connection between the identified task and the competences. Here we have this set of 12 tasks and 9 competence unit, right? And we ask professionals and experts to assess how strong is each digital task relate to each competences. So we ask them to assess the relations between these two big components. So in this way, we can establish the connection between tasks using the coexistence in this task competence relationship. And then we can map this coexistence relationship to a network structure. So let me give you an example how we can literally do this. So given that we have task 1 and 2 and competence 1, right? T1, T2, and C1. And we want to construct an undirected network using tasks as nodes. So the strength of the relation between T1, C1, T2, C1 determine the node weights, which will be the size of the nodes in the final network. Okay, then we see because T1, T2 are all connected with C1, meaning they coexist in these circumstances. So we can connect T1 and T2 together based on this coexistence relationship, which can be translated. If we translate this relationship into a adjacency matrix, then we can say there will be an edge or link linking T1 and T2 in the network. And the strength of this edge is, depending on the total weight of all T1, T2 coexistence relationship, which will finally be visualized as this particular bit of the network. And because we just use relations to construct this network, there's no causal effect. Therefore, the network is actually transposable, right? Here in this example, we see how to construct the task-based network, which means the network, in this network, nodes are digital tasks. But if we transpose the adjacency matrix by assessing the competences coexistence in terms of tasks, then we can have a competence-based network wherein all the nodes are actually competences. So these are the two types of network we can construct from this method. And once the network has been obtained, we then use the structure of the network to review clusters or communities. And for network community detection, we applied a well-defined algorithm called latent algorithm. So once the network has been obtained, the idea of the community detection is to find groups of nodes so that the intra-group similarity is maximized, right? And the intergroup similarity is minimized. And because in our networks, nodes are digital tasks and or competences, so those clustered tasks and competences might imply different groups of capabilities, right? Which might be seen as roles. And we start the empirical study by collecting expert knowledge using an online questionnaire. We have collected 22 responses, where 19 of them are valid responses for us to use. And as described, we analyze all of them in two ways: task-based networks and competence-based networks. In practice, the task-based detection is like you have a series of specific tasks, right? And now you need to form a team to handle them. And you want to know what roles should be included in this team, right? So you learn the roles basically from tasks. The competence on the other side, the competence-based detection is more like you already have a team, okay, which contains different members who have different competences from their diverse background. And now you need to assign roles to them, right? So you learn the roles from people's competences. So basically, these two ways of detection are two perspectives. The former is task-oriented, and the latter is people-oriented. So here is the visualization and analysis results. This is one of the task-based network from the questionnaire response. Different color represent different task clusters, and you can interpret the size of the node as the relative importance of the task, and the color of edge represents the total weight of the coexistence relationship, as we mentioned before, right? You can see them as more warmer the color is, stronger the connection is. So in this particular network, the algorithm, the community detection algorithm, returned 6 communities. However, what we have found from the rest sample network is that such community pattern keep changing, which indicates that people's perspective on interpreting different tasks could be highly heterogeneous, right? Which means different people perceive the same set of digital tasks and their interdependence in a different way, even though they are provided with the same definition of those digital tasks. Additionally, we can also find that those single node communities or the roles were difficult to interpret. They are separated from other tasks and form an independent role. Of course, more evidence is needed for cogent explanation, but one possible explanation is that they require distinct skills and capabilities or highly specialized skills, and therefore they are not strongly grouped with other skills. So to find a more convergent pattern, we aggregate all 19 networks to see the aggregated pattern. So we have 7 clusters here, so which can be seen as 7 rows, and there are 3 big clusters, row 1, 2, 3. What we found here is that those identified roles can be roughly aligned with some of the existing roles in organizations, but in the meantime, it reveals some interesting pattern. For example, as you can see, the row 1 contains data storage, data sharing, and analytics and modeling, right? So this could be a data analyst in an organization, but with a strong capability to perform data sharing tasks, which is very often less covered in practice. Next, we also have performance analyst and development operation engineer. There are all possible roles we identified with this network community detection method. And essentially, what we found here is that this rigorous method using qualitative data revealed a range of different perspectives for role discovery. So this way is quite innovative, right? Similar features have also been seen from this transposed network, which is the competence-based detection result. The network and its community structure vary from case to case. Again, if we took an aggregated network, we have 6 clusters here. And taking the purple row, the purple cluster as an example, it contains data curation and data privacy and safety. This is a very intuitive role, right? Considering the fact that if one have the competence to curate data, it is very likely that the competences on privacy and safety are also obtained. Likewise, this aggregate network also shows several single competence roles. One thing to highlight is that those single competence roles do not necessarily mean they only need to focus on this particular competence. On the contrary, from the network visualization, we can see these nodes are actually also connected with other competences, which means other competences are also required to support this role. But the possible reason why they are not clustered together is that those supporting competences might only be required at a lower or much lower proficiency levels, which means they are connected but not strongly enough to be clustered as a role. Okay, so this is now a very brief presentation on this exploratory study we carried out for digital and technical component in the competence framework. It's meant to exemplify that role identification can be attempted using a network approach. And the purpose of this study is to provide evidence and support for role development in the overall framework. And as we've seen from the results, this study could be helpful, but we still need more information to support and explain the role identification and more importantly, find a convergent pattern on the overall results. So for future work, this network approach could be taken forward by considering different types of networks, such as directed, weighted networks, and etc., to carry out deeper analysis on digital tasks, competence, and roles. And of course, using more sample data rather than just 19 responses from the questionnaire. All right, so this is the presentation of submission 42. Thank you very much for your listening. I'm looking forward to discussing with you during the conference session. Thank you very much.